do this on paper in the previous lecture. Now I want to show you how to do these problems in your head. So let's start with my favorite feat of mental math, squaring. Taking a number and multiplying it by itself. After all, two numbers can't get any closer than that. We already know the squares of the one-digit numbers, like 7 squared is 49. Let me show you the method that I use for squaring two-digit numbers in your head. With practice, you can do these problems faster than someone using a calculator. We'll start with the square of 13. Now, we've already learned how to solve this problem by the close together method, but let me show you a slightly more efficient way. At least you'll find the picture to be a lot simpler. Okay, so to square the number 13, now 13 is not a bad number to multiply, but what number close to 13 is much easier? 10, right? So I go down 3 to 10. Now, whatever comes up must come down. If I go down 3 to 10, to keep it balanced, I have to go up 3 to 16. So the first part of my calculation is I do 10 times 16, which is, of course, 160. Next, all we have to do is add the square of the number we went up and down. We went up and down 3. 3 squared is 9, and that's your answer, 169. Here, let's do another problem. Let's square the number 19. This time, the nearest easy number would be 20. So we go up 1 to 20, and if I go up 1 to 20, I have to go down to what? 18, right. So the first part of my calculation is 20 times 18. That's just 2 times 18 with a friendly 0 attached. 2 times 18 is 36, so 20 times 18 is 360. Almost done. All we have to add to that is the square of 1, which is 1, so there's our answer, 361. All right, let's do another one. Let's try 48 squared. Okay, now this time the nearest easy number is 50, so we'll go up 2 to 50. We'll go down 2 to 46. Now we have to do 50 times 46. There are two ways you could do it. You could do 5 times 46 and attach a 0, right? 5 times 46 is 230. Attach the 0 is 2300. Or you could take advantage of 50. 50 is a special number, right? It's half of 100. So if I did 46 times 100, I'd get 4600. Half of that would be 2300. So no matter how you do it, 46 times 50 is 2300. Almost done. All you have to add is what? The square of 2, which is 4, to get your answer, 2304. Now, numbers that end in 5 are especially easy, right? With a number like 65, you could go to either number, 60 or 70. You're going to get both numbers anyway. If you go down 5 to 60, you're forced to go up 5 to 70. 60 times 70 is 4,200. Add to that the square of 5, 25, to get 4,225. This was essentially the same shortcut that we learned in Lecture 1, right? What did we do in Lecture 1? We took the first digit, 6, multiplied it by the next higher digit, 7. 6 times 7 was 42, and then we attached 25. But what we were really doing was doing 4,200 plus 25. Okay, this problem's also easy. Anytime the numbers are near 100, that's especially nice, like 97 squared. We'll go up 3 to 100, down 3 to what? 94. 94 times 100 is 9,400. And what do we add to that? The square of 3, not the square of 7. Some people make that mistake. Don't do that. So you're squaring the distance. 3. 9,400 plus 3 squared, 9, is 9,409. So why does this method work? Here's the algebraic formula that explains the method. A squared equals A plus D times A minus D plus D squared. Here, A is the number that you're squaring, and D is the distance to the nearest easy number. Now, I don't actually think about this formula as I'm squaring, but it's nice to know that it always works. The formula works because when we multiply A plus D times A minus D, we get A squared minus D squared.